So we're going to be covering building an operational ML team from zero. So it's more of like a beginner track, and then we'll step into some use cases of how we're leveraging Databricks and Delta Lake at BlockFi. So just about me, I'm Anthony Tellez. I'm the head of machine learning at BlockFi. I was previously a principal ML architect at Splunk and a geospatial analyst for the intelligence community for the US government. My focus has primarily been ML for network security, so DGA and bot detection. I have patents in data visualization for security and fraud analytics, and applied data science and graph theory. Pre-pandemic, I was flying a lot, around 150,000 miles on average all around the world, helping customers leverage machine learning for different use cases in cybersecurity, fraud, and IT analytics. So what do we do at BlockFi? And also kind of like this is the layout of the agenda, right? So BlockFi cares primarily about having a data-centric culture. We want to use ML to provide a world-class machine learning service to our clients and internal stakeholders. The topics we're going to cover today is A, like what does BlockFi do as a company or as a business? How did we actually go from little to nothing to an actual operational use case in 6 months? Talk a little bit about the security challenges that we see in crypto, in the crypto space, and then like a little primer into graph analytics and why we ended up building graph analytics within Databricks to do what's called crypto tracing. So one of the things that we have at BlockFi is a credit card. So we offer a credit card partnered with Visa. Allows you to basically spend things. You get those rewards paid into your BlockFi account as Bitcoin. And one of the things that we're highly focused on is a future where every person is able to hold crypto, leverage crypto, and make financial literacy available to all different parts of the world, right? So we want to use the blockchain and use DeFi protocols to allow customers that might not have access to funds today or have the ability to have financial services, make that available to them through our platform. So we kind of split the business to two different types of customers. There's what we call retail customers, right? And so what a retail customer is just your traditional person that wants to buy crypto, doesn't necessarily have like all of the knowledge necessary to like run their own nodes and mine crypto and do all those types of things, but they want to be able to hold it for either long-term investment or they want to use it to buy things, right? And so what we have in terms of products, as one of them is the wallet, right? You can just purely install the app from the App Store, link your bank account, and then buy and trade whichever crypto that you would like to own. So that could be Bitcoin, Ethereum, Dogecoin, etc. One of the other things we allow customers to do is if you are crypto native and you have, let's say you've been investing in Bitcoin for a long time and you want to collateralize that crypto to like buy a house or buy a car, we allow you to take out a loan against that crypto, right? So it allows you to actually get fiat for crypto without having to actually make a sale of your crypto, right? So trading it on the market for fiat, like instead we allow you to collateralize that. Obviously trading I've covered, and then I talked about the credit card. The other thing that you can do is if you have a large amount of crypto assets, you can actually get what's called the personalized yield, and that allows you to actually earn interest or yield on your crypto deposit. For institutional clients, we have what's called Prime. So you can think of it like a more advanced trading platform allows you to do things like leverage your crypto assets, right? And be able to do things like limits and stop orders, et cetera, right? More advanced trading options. We also allow corporate lending. So customers that are in the crypto space that want to do, let's say, mining, we can allow them, we can help them to take out a loan, right? Or lend them crypto in order to get started with their business. And then private client offering, basically similar to what we have, right, for a retail client, which is the personalized yield, but this is generally like an institutional client. All right, hopefully everybody now understands what we do. If not, I'm available for questions afterwards. So building an operational ML organization takes a lot of work, and we're going to kind of step through what was our process, why did we use Databricks to do this, and what advantages did it give us as a Web3 company. So essentially what we started out with was we didn't really have a native data strategy or like a team that was focused on like how do we scale out and begin to enable ML within the crypto space. So we started with team building and organizational collaboration, trying to figure out what are the things that make sense for data science in the crypto space, right? What are the things that we don't know about or we would like to be enabled, whether it be trading or crypto tracing or being able to just have more real-time analytics on how funds are moving through our platform, right? So partnered with different aspects of the business, so finance and marketing and the anti-fraud team, compliance, trying to understand like how do they solve these problems today or do they lack visibility by way of the processes that they have. So we kind of scoped out a POC, said, hey, we want to at least be able to see our withdrawal data, right, within Databricks. How are funds moving on the platform? How are funds leaving the platform? Where's money coming from? And can we do proper KYC, right? Know your customer regulations through Databricks analytics. So this is basically the model. This comes from Gartner. We went from, there should be like a level 0 on here, but it was too hard to like redo the image, so I left it off. So we started basically at level 0 where there really wasn't a platform. We had like some data silos, different teams had different tools. Marketing had one tool, finance had a separate tool, engineering was putting data into Redshift, into other data stores, and then security had its own logging platforms that were totally separate but also had duplicated data. So we kind of scoped out this use case, and then we started executing along this plan over 6 months to say, hey, we want to be at level 3, which is we are actually putting ML models or analytics into our actual reporting processes for deciding the health of the business, right? So we've gone from basically, hey, ML is hype to let's actually experiment, right? And we did like a 2-month POC where we were taking our data, statically, not real time, building analytics and dashboards off of it, and then trying to understand like, okay, what would this actually look like to begin getting real-time data from the blockchain or from our live production databases. And then the third phase was, okay, now that we have a process or a sort of process where we could get almost real-time or delayed data into Databricks in a repeatable fashion, can we start building analytical products on top of that? So dashboards that allow me to get a customer 360 or being able to take a wallet address and trace, hey, is this wallet on the US sanctions like OFAC list, or do we see that this customer failed KYC for some reason? Right, that might be related to US sanctions or a sanctioned entity. This is the actual journey or the roadmap that we kind of prepared high level. So bringing the platform together, right? We all kind of as a group said, hey, you know what, let's go ahead and try this Databricks thing out. We also got Confluent Cloud at the same time to say, hey, we want to do event streams eventually and do real time. So we POC'd those things together, and they actually work pretty seamlessly, getting data from Kafka into Spark. And then we began moving into ETL, like what do the ETL processes look like for Spark using Kafka? What does it look like to integrate with a S3 layer that might be hosting Parquet files or static data? And then what does it look like to pull data from blockchain nodes or things that are third-party REST APIs that we need in order to know about our current custody of crypto funds? One of the things that we moved into earlier in the process that most people might not is an ML cloud service. So we ended up partnering with a company called Graphistry, which provides NVIDIA Rapids as a service. And they support PySpark data frames being transferred back and forth as well as Apache Arrow. And so we would take crypto transactions, push those to Graphistry, and we would get a graph back. like a process graph, right, leveraging GPUs. And this would give us a pre-cached dashboard and allow us to then look at that dashboard and start doing queries to say, not just, is this wallet blocked, but does it have a relationship with a entity that might also be blocked? All right, so we'll step into the security challenges and business problems that we saw as we went through this process. So some of these are unique to crypto, but some of these can also be applicable to other fintechs. In the crypto space, obviously, we're early in regulatory frameworks. There's a lot of changing legal things that are going on, right? Whether it be Ripple and the SEC or other companies, right? The speed of activity is also another unique challenge. So one of the things with crypto is once you've traded it or once you've moved money from a wallet, it's gone. Like there's no take back, right? So in the case of moving money, right, with your bank, you can kind of cancel that ACH or you can do a request a reversal. There's no takebacks in crypto. Like once the money is written to the blockchain, that's immutable. And that's part of the entire reason why you use the blockchain. You have 24/7 live trading, right? So typically if you go on an exchange like Binance or Coinbase or KuCoin, you can actively see people buying and selling crypto, right? Whereas the traditional stock market is from 9 to 5, right? Monday through Friday. So you're consistently seeing money either being moved or being pulled, like deposited into new accounts or being withdrawn out of new accounts or being traded, right? Trading between USDC and Ethereum or trading between Bitcoin and Tether. The other challenge that's kind of unique is a lot of crypto nodes, like if you're going to run your own oracles, have to be publicly connected, right? So for a lot of security people, that's a scary thing to have a node that's communicating with all kinds of other, other unknown entities on the internet, right? And so how do you actually make sure that thing's secure? How do you make sure that those connections aren't anomalous or they behave in a way that you expect? And then you have like the actual cryptographic attacks, like a 51% attack if somebody takes over a particularly small cryptocurrency, right? If they spin up enough miners, they can basically take over the protocol and then change rules about mining and how rewards are paid out. And then there's also the privacy issues that come with what are known as like dust attacks. So people that are literally just spraying crypto, sending funds all over the internet, trying to uncover wallets and then trace those wallets to figure out like, who does this belong to? Where does money move after it's hit that wallet? Does this wallet actually exist? This is pretty typical of governments, but it's also used by other nefarious like criminal enterprises. So a little bit on like where we came from and then where we went to. So we had like this DIY AWS Redshift architecture. One of the biggest challenges we had obviously with Redshift was the scale out pattern just really wasn't there. And we had to actually build IAMs and provision users on a per credential basis. So me coming from my security lens, like that's a problem, right? Like you gotta rotate credentials, you gotta scope those IAM permissions. That's a manual process, it's not really automated. And it's difficult to take multiple IAM roles in AWS or across multiple Redshift clusters to say, what is the union of permissions that somebody has to certain sets of data, right? And so that in and of itself made us really think, hey, there has to be a better way to do this, right? Besides trying to do this manually, hiring auditors or having security people, an entire security program management team dedicated to just figuring out what are the union of permissions that people have. So what we did as a part of our POC was we started putting data into what's called AWS Lake Formation. So it's cheap S3 storage. We could basically take DMS replication tasks from Redshift and write Parquet into S3. And then from Databricks, grab that data and pull it directly into Delta tables. The nice part about this was at the time, we weren't a Databricks customer that had the ability to use custom KMS keys in our workspace because we were in POC, but we could use those custom KMS keys as part of our POC at the S3 level, right, and program those on the Spark clusters. So we were able to get the level of security that we wanted as we were moving through the contracting phase with Databricks. The other thing that was nice was it also allowed us to integrate more cleanly with third parties. So if we wanted a third party to be able to write into our lake, we could scope out a bucket, a role, and a cross-account permission to allow them to write into the lake, right, and then deliver whatever that data was. If it was marketing data or TV data, et cetera. So we ended up with that as like our true raw, and using the LakeHouse architecture, right, with Delta Lake to start our refinement from bronze, silver, and gold, right? And so we opted for this primarily because we are a big Okta user, and we could essentially scope user roles and permissions to tables within Databricks and within Delta Lake. And so now when we looked at the union of someone's permissions, we could basically say, hey, finance people have access to things that are scoped to finance, security to security, fraud to fraud, customer service to like this super small set of data that they need access to. We also had the ability to use something called SCIM, so SCIM 2.0 with Okta allows you to actually update the groups within Databricks, and we heavily utilize that, right? So we could actually set group membership, and somebody could be a member of a group in Okta. We can move that. If they move teams, right, their permissions also evolve with them moving teams, so there's not a permissions creep for that user if they move from security to engineering or engineering to marketing, right? Like if they're jumping around, they don't continue to just aggregate permissions. They move within Okta, so they also move within Databricks. So we're going to take a step back and now jump actually into the use case. So that's kind of like our deployment methodology, why we did Delta Lake, and then this is what we ended up doing, right? So all of that was like the ETL piece and the infrastructure piece, and then it was like, hey, now that we've simplified this, we can actually go chase the things that the business cares about, the security pieces, the traceability of crypto funds. So high level, this is a blockchain flow, right? The idea here is that like each block within the blockchain has a hash and it's linked to a previous transaction. This is why it's immutable, and this is why it's important in crypto, right, to get it right. So when I send funds, it's automatically included within the next block. So if I screw that up, send it to the wrong address, oh well, the money's gone, right? Or the crypto's gone. So you got to be like very cognizant of like where are you sending money to, where's money coming from, because once it's on the blockchain, it's really hard to reverse it unless you somehow control that other wallet and then you can like send it back. The other parts that are problematic in security, right? People care about privacy and security. That's probably they're a very vocal community on Twitter, right? In terms of supporting different layer 2 or layer 1 crypto protocols. Like I said, money, basically, there's no takebacks. Once it's gone, it's immutable, it's on the blockchain. And there's also a lot of difficulty understanding more complex things like smart contracts or DeFi protocols for security analysts, right? And so understanding like what's written within a smart contract can be very difficult because it's, you're just literally parsing code, trying to understand where can money move, what are the rules related to that smart contract, and how do you respond to that, like if you've somehow signed on to that smart contract with a wallet that has a lot of funds associated with it. The other thing is obviously, certain crypto are used essentially for ransomware, and also they're used for moving money. That's also another avenue of like where we have to do our KYC, right? We have to understand like where's money coming from? Like is this wallet associated with a scam or a threat actor group that's actively targeting things like the Colonial Pipeline hack, for example, right? Like those wallets were well known to us and to everyone that the FBI communicated that to. So we would have to do our due diligence to make sure, hey, have we accurately assessed like what is our risk or exposure to that? If you've ever seen Silicon Valley, right, I think it was the season finale, there was like a 51% attack, was like their whole kind of narrative at the end. But it is actually a serious thing in like low cap coins, potentially, where somebody can basically spin up a lot of miners, and essentially take over the protocol itself. And once they have the ability, once they've taken over, right, they can actually start changing things like mining fees. They can reject transactions, so moving money around that you may not want them to move around necessarily. And obviously, if they're targeting you in particular, right, like move funds out of your accounts that you didn't want moved. The last piece is dust attacks. So essentially, this is what's called the spray and pray in crypto. So essentially, somebody is sending really, really small amounts of Ethereum or Bitcoin to a bunch of addresses. They're generally doing this as a bot. They're not doing it personally, right? And they're just trying to enumerate wallet addresses. Does this wallet address exist? If it does, how much money's in that wallet address? And then if there's enough money in there, maybe I target that person with some kind of social engineering, or I try to phish them and get access to their wallet so I can take their money, right? The other piece to this is obviously surveillance. So governments will use this to try and understand, hey, do these wallets exist? And if they have large amounts of funds and they're associated potentially with a terrorist organization or financial crime like network, then obviously you're gonna kind of track and see where does money go, what exchanges are they trying to operate with, et cetera. All right, so we're gonna step into, with that, how do we actually solve for some of those security problems using graphs? So essentially with a graph, right, we're trying to build connections, and we're trying to understand, hey, does this wallet address have any relationship with another wallet address in our network? Or does this customer or this account have a shared wallet address and maybe they got targeted by a scammer, right? So there's tons of scams that happen on Twitter. You know, send me 0.5 Ethereum and I'll send you 2 Ethereum back. People do actually sometimes believe that and they try it. Or send me this and I'll airdrop you some new token or some hot NFT that's coming out, and they get nothing in return. So it happens. There's people, everyone's trying to make money somehow. So when we're looking at that from a graph perspective, we can actually start to see that interconnectedness of accounts or wallets, right? And what is the relationship or the risk associated with those graph connections? So why a graph, right? We can figure out important nodes in a network. If you're familiar with NetworkX, right? We can start to see things like, hey, what is the, let me see if I can find an account with a shared IP address, right? It doesn't have to necessarily be wallet, it could be account level. Accounts with shared wallet addresses or shared behavioral patterns, like they have a shared session type of behavior, or they're coming from the same VPN nodes or Tor nodes, right? Or the same device ID. You can start to do a lot of one-to-many connections and then visually inspect those and find nodes or graphs or subgraphs that have properties that might be risky or that you would want to kind of dive into and analyze. So like I mentioned, we're using a product called Graph History, and it's as easy as those literally 4 lines of code. In Databricks, you have to do something called display HTML in order to actually have it render in page. So what we do is we take a Pandas data frame, or you could use a Spark data frame. It also supports Apache Arrow. We build out the relationship. So in this case, we have a source wallet address and a des wallet address. We have the amount of current currency that was sent, and then we have what was the asset. It was BTC, right? We take that data frame, we pass it to Graph History, we say, hey, this is the source, this is the des, build us this hypergraph or this graph, and then it returns to us a simple graph saying, hey, here's the connections, and we can start adding properties to it, like how connected are they, what's the shortest path, et cetera. And this is actually what I'm talking about, right? Start doing centrality measurements. So this is where you start getting into feature engineering for graphs to start to understand, like, hey, how influential is this node, right? If I'm looking at IP addresses, or I'm looking at account IDs, or I'm looking at a specific wallet, what's the, how close together are these nodes? Like if they cluster together really well, they might be part of the same criminal network, right? Or terrorist organization, or scam ring, or like whatever your use case is, right? Or if it's IP addresses, maybe they're all running in the same infrastructure, potentially. The other piece that you have is the betweenness centrality. So like, hey, if I wanted to go across this super graph or this hypergraph, like which nodes are the most important to like do that traversal? And that can also tell you something about like how close the graphs are compacted, or if they're or the relationship between like the furthest point of the graph and the longest one, right? So that'll tell you like, hey, this entire structure, like maybe these two subgraphs are actually connected through some intermediary service, like an exchange or some kind of mixer that's used for like mixing funds. And obviously the importance of this is to quantify wallets, right? So like I'm using these just simply to say, do I see these nodes connected to anything that I already know is bad, right? So now I'm able to actually quantify risk. And that's what we're doing here is like quantifying risk. So we do threat intelligence mining using those graphs to start figuring out, hey, are these wallets connected to things that we know are bad? If we know they're bad, then how do we start associating them with traditional threat intelligence, things like VPC flow logs, looking at transactions for an anomaly, we're looking at VPC flow logs to identify threats and say, okay, this IP address is bad. It's also associated with this wallet address, so now that's a property of that. So now we have some additional risk we can start modeling to say, hey, maybe all of these wallets that have an association with something that we know is bad, coming from VirusTotal or any other open source threat intel, starts to have a property or a risk property that would make us second guess clearing those funds being withdrawn or being received onto the platform. For VPC flow logs, basically we're looking at like, hey, how do we find outliers? How do we do anomaly detection? And then being able to understand how do we take that and then start to build a graph from it to start inferring additional properties about our existing wallet infrastructure or transactions that are coming in from the blockchain. One of the things we were using essentially was Fivetran. So we were pulling a bunch of data from VPC flow logs that are stored in S3, which is something like 22 terabytes a day that we were ingesting into Delta tables and then processing that to try and find, hey, are these matching our anything in VirusTotal? If we have a match, can we then pair that back up to a transaction or to a device? If we can link to a device, then we can link to a customer. If we link to a customer, we can look at like wallets and money movement to potentially find, hey, not necessarily is something happening at a customer level, but is there a potential for that customer to have been ATO'd, right? Like that's the other piece to this is making sure that our customers are safe. So this is a little bit on the enrichment and anomaly detection. So like I mentioned, we're using MaxMind, VirusTotal to get geographical context to understand like, hey, do we see a login from somewhere we've never seen before, right? Do we see a login from a high-risk jurisdiction, right? Places that are on the US sanctions list that obviously we don't want them transacting with the platform. And then doing a little bit of behavioral analysis to figure out like how much data was transmitted, like does this kind of look like a bot that's trying to access accounts and failing or successfully getting into an account? And are they changing any properties of the account, like adding a wallet address, et cetera? And like, obviously, what is that wallet address? So this is what the visualizations actually look like in Graphistry. So this is, when we pass the data frame, we actually get an interactive session or notebook within Databricks. That's a D3 visualization. It allows us to actually change properties. We can also search within here. It supports some graph-like search that allows you to then say, hey, I want to look at a very specific IP address, or I want to find things that have a very specific property within my hypergraph, and then drill down into that, and obviously share that with the teams that are going to be responsible for it. So in our case, like it's compliance and KYC. Like, hey, we see this thing that's connected to whatever. We want you to be able to action on it or block that withdrawal, or we need to do some kind of reporting on it, right? And additional KYC on that particular account. The other piece that we integrated was we leveraged Kafka. So what we do is we actually produce that graph. That graph is static, and it's a static link. So we put that into a Kafka message, and we deliver that to a Slack channel for security and for our other teams. So when they get that notification in Slack, that graph view that I showed here, they actually get that particular view, so they know exactly what they're looking for. So, hey, this triggered some rule in virus total, or it triggered some anomaly rule, or it's like it triggered something else with our OFAC sanctions list. Go ahead and load this graph and get to the event data that you need in order to start your investigation. All right, I'm going to skip to this because I got like 4 minutes left. So basically, how we're using all of that is we're attempting to build trust, right, within crypto. So we want to use our knowledge of graphs and our knowledge of data to start understanding what are wallet addresses that are risky to do business with on the platform, and how can we improve and instrument our KYC processes faster and automate those. So in the event that we have to file what's called a suspicious activity report, we have all the information available to us automatically, and a expert in the actual domain, like an AML analyst or somebody like that, can actually verify like what they have is what they need in order to send that on to the US Treasury. We're talking about risk quantification. One of the things that we're using to do this really quickly is Coinmetrics. So Coinmetrics has a Python library that directly turns crypto data into Pandas data frames. And that's actually the second piece to this, is we can start pulling real things off the blockchain, right? We're not just pulling our things that we're scraping, but actually fetching data to enrich in real time, like, hey, did that transaction actually clear? What block was that associated with? And then parsing any other metadata that comes back from us. In this case, we're just simply pulling pricing information. This is a simple example I stole from one of their blogs, but it essentially works with any of their APIs that are supported. And the nice part with that, obviously, is then you can use things like Chainalysis and AndChain to start layering on top of that real-time blockchain information that comes back, and then your own internal KYC databases that you might have threat indicators in, or customer IDs or identities that might be risky that you don't want to do business with, or that are sanctioned by the US government that comes from the US Treasury. And we're generally just kind of following a bad neighbors approach. There's a book by the Verizon security team called Data-Driven Security. It's still valuable to reference, but that's essentially the approach we're using. Like, all the old things are new again, basically. And this is just an example, again, of like using centrality measurements, right? Finding shared wallets, like we found like referral scams, dust attacks, like money laundering. Any of these like use cases or things that you care about within Web3 are applicable, obviously, with the graph. All right, key takeaways. So like from our journey, it was basically like, that was our use case. We actually started kind of with that a little bit, like how do we get better transparency into our crypto funds or withdrawals, things that are happening within our wallets and our custodial information. And we collaborated with our teammates to figure out, okay, how do we actually build this? How important are those to the business? Prioritize them. We adjusted our architecture as necessary. So some things we had like, oh, we're just going to do S3. And eventually we realized, hey, you know what? Maybe we should do like Kafka for some of that stuff. So we were able to quickly adjust and adapt on that. And then operationalizing by figuring out like, what are the KPIs that an exec on our team or a VP would want to know about the product or about operations that are ongoing within compliance and AML and KYC. And then I don't know why this is at the end, but I forget what I'm supposed to say here. Yeah, so this is not financial advice, so please don't invest in crypto securities based on things I say. That should have been at the front, but whatever. Thank you.
So I have a question about ingesting the VPC logs through 5chain. So we use 5chain as well, but we find it a little bit expensive. So why don't you consider using solutions like autoloader from Databricks to ingest the VPC logs?
Yeah, so we actually turned that off in all transparency because it is expensive. We ended up doing, autoloader didn't exist when we started this project. But now that autoloader does exist, that's the better way to do it.
Enjoy the rest of the summit.